In this lecture, we're going to talk about static methods and static variables and how they differ from instance methods and instance variables. Let's start with a little bit of a definition, and then we'll move on to a visualization of what we're talking about. When I use the term instance variable and instance method, or even the term instance itself, what I'm talking about is an actualization or a concrete realization of a class. In other words, an object. We've used the new operator, and we have gone ahead and constructed an object in memory. So for each object that we build using the constructor and the new operator, we are basically making unique copies of any properties that that object has in memory. In other words, we know that each object has state and it also has behaviors. So every time we make an object, what we're doing is we're making unique copies of those state properties and those methods in memory. One of the things I'm going to point out in this lecture is that I'm going to keep saying that objects have their own copies of variables and methods, but when it comes to methods, that's not exactly true. There's some memory management that happens in the Java virtual machine, and so we can imagine that every concrete object, every instance of a class has its own copies of methods, but it's actually managed in memory a little differently. So just pretend with me for this lecture. So let's visualize an object. I keep saying to you that objects have state and they have behavior. And I just said to you that an object is an instance of a class. So this circle is going to be how we want to visualize each concrete instance of a class. In other words, something that we have actually built and exists in memory. Objects are often visualized with this diagram. You'll see it in a lot of different books and on different websites. If you may have already seen it already in some of the reading I've assigned. So here's the deal. Important methods go in the blue area, and one of the things you'll notice is that inside of that blue area there are a bunch of what I'm going to call instance variables. These are the properties of your object. In other words, these are what track the object's state. Notice that the properties are protected. If you think of this like a castle, you can think that the methods are wrapped around the variables. In other words, last lecture we talked about this idea that we want to keep our instance variables or keep our object state private so that we can protect how those properties are actually modified or changed so that they don't have any errant values added to them. What's really nice about using this type of visualization is that we can really see what I mean by encapsulation. Again, this idea that the state of our object is protected by methods and that we as the programmers can scrub data as it comes in and out of our objects so that we know that the state of our object will never be put into a situation where it's corrupt. So again, in the blue area, we have important methods. Inside of that, we have properties. So here's a class, really basic account class. We're tracking one property, account ID, and we've got one behavior that allows us to get account ID. So on the right, you will see how that appears using our new object visualization. So I've called the constructor on this object, and now I've got one in memory. So I have one copy of the account ID variable in memory, along with one copy of the getAccountID method. Now I'm going to call the constructor again, and this time I now have two copies of the account ID in memory. And because account ID is of data type int, we know that in Java it takes up 32 bits of memory. So right now I've got two copies of account ID, so I'm taking up 64 bits of memory. Let's call the constructor again. Now I have three objects in memory, therefore I have three copies of the account ID property in memory, right? Taking up 32 bits times 3, right? 96 bits of memory. So what we've got here now are three different copies of this object. That means we have three unique copies of account ID and three unique copies of the getAccountID method, or at least that's what we're going to tell ourselves at the moment. So let's reinforce that idea. Three unique copies. Every object instance, if that variable is an instance variable, in other words, not tagged static, every variable that is contained in an object will be created anew every time we construct the object. So for every object, we will have a unique copy of each piece of each instance variable that is being used to track that object's properties. So how does this differ from static variables? Well, static variables are a little bit unique. Whereas with instance variables, we have one copy of each property for each object, static variables are shared amongst all instances of a class. Therefore, there's only ever one copy of a static variable in memory. And a couple of properties that you'll see as we play with these is that we can change static variables using both static and instance methods. Let me say it again. We can change static variables using both static and instance methods, but notice that we can only use instance methods to change instance variables. And as you play around with this, you'll realize that it makes sense. So let's visualize this. Here's the same class we looked at before, but now I've added a static method, or sorry, a static variable. And if you look, I've still got my standard get account ID object up there on the right, and it's got its single copy of the account ID property in memory, but you'll notice over here in this little cloud, which I have to represent another location in memory, I've created one single copy of the type variable. And we know that that type variable is actually tied to this object. So we want to maybe be able to access that type variable. So I went ahead and I added another public method. Notice that this is an instance method. Therefore, the account object now has two methods associated with it, a get account ID method and a get type method. This is also to enforce the fact that instance methods can access static variables. So we've got an instance method that lets us see that. Notice again, there is one copy of account ID with this one account object, and now there are single copies of the get account ID method and the get type method. Let's go ahead and create another object. Now I've got two copies of the account ID property in memory, and I've got two copies of the get account ID method and two copies of the get type method in memory. But notice I still only have a single copy of the type variable in memory, and this will continue. The more objects I create, there will only ever be a single copy of the type variable in memory, and that means that static variables are shared by all instances of a class. And if one object changes that static variable, then it obviously changes for all of those things. And the example I always like to use is like an end user licensing agreement. If the objects are programmers and Apple goes and changes their agreements for, programming an app on the iPhone, then it changes for every programmer. So there's only, in this case, one copy of the type variable in memory, and it is shared by every object or every instance of that class. So what are static methods? Well, a couple things that we want to talk about first. Static methods can only modify static variables, and when you think about it, it kind of makes sense because you don't want your static methods to be able to reach into a single object instance and make changes. The other thing about static methods is that they are associated with the class and not individual objects. Same as static variables, by the way. They're associated with the entire class and not, say, a specific object. The other thing that we'll notice is that when you call a static method, you call it with a class name and not with an object reference. So in this case, we've already seen the use of static methods, and this is why it's really important for you to start capitalizing class names. So how do we call this thing? Well, notice I've added a new method in this case, and it's public static, and it's called say hello. And when you call the static method, all it does is print hello. And you'll notice the way I've called it is by using the name of the class, account with a capital A, and say hello. Also notice I put the say hello method into my little cloud to indicate that now there will only be one copy of this method in memory. And again, we're just visualizing this idea of copies of methods in memory to help us understand this topic. So a couple notes and reminders. Instance methods and static methods can change static variables, but static methods cannot change instance variables. Read that a few times, pause the video. It's an important thing to remember. Static methods are often used like classic functions if you come from a procedural programming background. Oftentimes I see people get into object-oriented code and they want to make everything a static method because they're used to functions from other languages. What's really nice though is we can use this power in a sense to provide processing that should not be tied to an instance. And again, if you look at the math class or the string class, but the math class is the best example of an entire class that is just existing for the purpose of providing you with some basic math functionality. I believe everything in that class is static. So take a look at the math class to see how why they've chosen to provide a purely static class that allows you to just process math functions in a way that you may need in your program. And also take a look at the string class to look at what they've made static and what they've left as an instance method. And that's really the best way to start to understand how to separate what should be static and what shouldn't. So in the real world, we can think of some examples of what is an instance variable or method and what is a static variable or method. So again, just to kind of simplify all this, when we say instance variable or method, what we mean is that these items are related to a specific object. And let's say like my car, it's one car, it's my car, the transmission breaks. My transmission broke, yours car is probably still running fine. Let's say I have a pet goldfish. My pet goldfish dies. Well, if you have goldfish, your goldfish are still living, because these are instances of transmission and a single instance of a goldfish. And, you know, they're only affected that single instance. And if I'm drinking a soda and my soda goes flat, well, your soda didn't go flat. You might not even have opened it and started drinking it yet. So these are instance variables or methods. Single instances, things happen to just that one instance. Now we think about that in relationship to static variables or methods. These are items that are related to an entire class of objects. So if there's a product recall, let's say for example you've got a crib for a child, they're always being recalled. Every single crib that was made by that manufacturer gets recalled. So that is a static, something that is, the recall or on that item or the warranty on that item is tied to all instances of that class. In PA, we pay sales tax on classes of items. You might choose to store that sales tax in a static variable, so you don't have, 5 billion copies of a double in memory that just tracks 0.06. And in that case, if you also wanted to change the sales tax, if it changes, which it probably will at some point, you only need to change one variable instead of iterating over billions of objects and changing the sales tax for each individual object. So again, sales tax is related to a class of objects and not a specific object. Next thing would be like if you're in a union or a collective labor, collective bargaining situation, you might have a labor contract, and that labor contract is one contract that is tied to everyone who works under it. So again, many instances sharing a single contract. So these are kind of some things that are just instance-ish or static-ish. So hopefully this quick lecture was helpful to you, and if you have any clarification or need any additional clarification, please post to the discussion board and take a look at the reading and let me know. Thanks.